This is number 50 in chapter 18, and it asks us to use line notation for an electrochemical cell. And so it asks us to go back to a prior problem, and so I'm just going to pick one of those. And so here is our reaction. So those are our starting materials, and then our products are nitric oxide and then some other species water, and then 3 coppers that are +2. So here's our redox equilibrium, and we want to use it writing line notation, which is that kind of cell shorthand that I showed you for representing a cell. And so we need to write our anode on the left and our cathode on the right, so we need to realize what is being reduced and what is being oxidized. And so our copper here is going to be the species that's going to be oxidized. It's going from copper 0 to copper +2. And so we'll be losing 2 electrons, and then that means that our nitrate that's aqueous is going to be reduced to nitric oxide as a gas. And so if we balance that process out, we'd have to add 2 H2O's, and then we'd have to add 4 protons to get this balance as far as our atoms. But if we look at our oxidation number, our oxygen would have a total of -6, so that means our nitrogen atom is going from a +5 oxidation number to a +2 oxidation number, and so it's accepting 3 electrons in that process. So just to write this again with a little bit more space, we would have to have 3 electrons plus our 4 protons plus our NO3. Right, and then the whole balance reaction would come from the cross multiplication of 3 and 2. But when we're writing a cell representation or a line representation for a cell, we don't really need to worry about the stoichiometry. We just need to write the elements, and if they're being oxidized, reduced, or if it's a molecule being oxidized or reduced. So here is our oxidation. Remember, our oxidation is going to be at the anode, and then our bottom one is our reduction, and that's going to be at the cathode. And so that's how we write the cell, with our anode on the left, the cathode on the right. And so we'll begin with the oxidation. Our copper is an electrode. In this case, it's the anode. And so then we represent the line, which indicates a phase change. And then we would have copper +2 in solution. So that's the anode part of the cell. We then have our double vertical line there, which is indicating the salt bridge. And then we write what's on the cathode side. And so for the cathode side, we have nitrate, we have protons, right? And those are both aqueous. But our nitric oxide is a gas, so we actually have to use another line there and represent that there is a phase difference. And so for that nitric oxide gas, that's not saying it's a cathode or an anode. And then we have to have another line to indicate the actual electrode. And so since for the reduction we're talking about a system that's aqueous and gaseous, we need to have an inert electrode in order to just help with the transfer of electrons. And remember, we can use platinum or palladium for that type of process. So this is the line representation for the reaction that we have above. Again, we had to break that down to the oxidation and reduction half reactions, and then we represented that using line notation with, again, our anode on the left, our cathode on the right. Our lines here are representing divisions, right? The division between solid phase and aqueous phase. The double line here, remember, is always our salt bridge, which is separating one half reaction from the other half reaction. We go to the cathode side. Again, we have these aqueous species, the nitrate, which is being reduced, but when it is reduced, it turns into a gas, nitric oxide. And so even all of this is going on in that cathode portion of the cell. We're going to show that vertical line because we have an aqueous system and a gaseous system as part of that reduction half reaction. And so since we don't have any solid as part of that half reaction, that's why we use an inert electrode for our cathode. In this, platinum or palladium are the most common examples used. That is number 50, chapter 18.